Hello, welcome to Getting Started with Circuits, Electronics for Total Beginners. This is an extra video lecture to go with the Electronics Mastery course, and it's designed to help you if you have forgotten everything you once knew about electronics from school, or if you're just a total beginner and you've never done anything electronics before. It's not a complete description of anything, it's just aimed to build up a mental model which you can use to help you understand later lectures in the course. So what we're going to use is a very simple circuit and think about current and voltage and resistance, what they mean, and try and come up with an imaginary an imaginary model which will help you try to picture what's going on inside a circuit. So this is the circuit we're going to be looking at. It's just a cell, and the cell symbol is this pair of lines at the top. And the purpose of the cell is to take its stored up chemical energy. If we cut open this cell, this is just like an Energizer battery style thing. Inside that cell there is some Golgi chemicals and there are some bits of metal, and those things together are a store of chemical energy. The job of the cell is to turn that chemical energy into electrical energy, and the electrical energy then flows around the circuit until it hits the light bulb here. This circuit symbol at the bottom is a light bulb, and the job of the light bulb is to turn the electrical energy into light energy. So that really is the purpose of any circuit. It's the transfer of energy from one type of energy to another, from one place to somewhere else. Sometimes in more complicated circuits that energy can be in the form of information, and we're just transferring information from somewhere to somewhere else, but it's always going to be an energy transfer behind it. So how does a circuit do that? It's all to do with the movement of charge, and more specifically charged particles called electrons, which are flowing around the circuit. Now electrons are tiny subatomic particles, far too small for us to deal with individually, so we treat them as large groups of electrons. We picture them moving around the circuit in big gangs, and we call those gangs, those groups of billions and billions of electrons, we call them coulombs. So coulombs of electrons are passing around the circuit, and they are like our delivery trucks. They are moving around the circuit, delivering energy to different parts of the circuit that need it. How quickly and how many of those gangs of electrons are moving, that is electric current. So electric current is the rate of flow of our gangs of electrons, the rate of flow of charge, the rate of flow of coulombs. The way to increase the current is to either have more electrons moving or make the same number of electrons move faster. So those electric charge carriers, the electrons, the coulombs, are moving around the circuit like delivery trucks around their routes around the country making their deliveries. And what they're delivering is energy. And in circuits, we don't deal with energy in the traditional way, in terms of how many joules of energy we have. We have a new quantity called voltage. So current is how much charge is moving and how quickly that charge is moving. Voltage is how much energy each one of those delivery trucks, how much energy each one of those coulombs of charge are carrying. So if each coulomb of charge, or if you imagine a single coulomb of charge in the cell is being given 3 joules of energy, that means the voltage will be 3 volts. It's 3 joules per coulomb. Then as those electrons move around the circuit, they deliver that energy. In this circuit there's nothing else other than a light bulb. So that light bulb will be receiving all of the energy the electrons are carrying. So for every coulomb of charge, every gang of electrons that passes through that light bulb, it will receive 3 joules of energy, 3 volts. And then the coulomb will have no energy left. It will get back to the other side of the cell with 0 joules of energy, 0 volts. So just like a lorry making deliveries, it starts off with a full load, and that gets delivered as it goes around its route, and it returns back to the depot, to the warehouse, with no more energy, nothing left to deliver. But the lorry is still the same lorry. We don't lose the current, we don't lose the electrons, the delivery vehicle, we only lose the cargo. And the third quantity we need to be aware of is resistance. Resistance is simply a number we give to components that tells us how easy or how difficult it is for the electrons to pass through that component. The larger the resistance, the harder the electrons find it to get through that thing, so the more energy they lose as they pass through it. If you keep that model in mind for the main 4 lectures in the Electronics Mastery course, I think it will help you understand things a little bit better. So, good luck with the Electronics Mastery course. Do please leave feedback on Udemy, leave a review. It's very, very much appreciated. And if you have any questions or any comments or anything you want to ask me at all throughout the course, do please feel free to message and ask. Post it as a question, send me a message, I will get back to you as soon as I can. So good luck and enjoy the course.